everything. I'm going to move, Chair, because I think there's too much background I don't need. How's the floor? Any feedback? Hello?
Yeah, we can hear you, and I think we're live.
Great.
First of all, thanks a lot, everybody, for joining the webinar today. And as you know, we have Professor Paulo from Liverpool, John Moores University with us today. So thanks a lot for your time, Professor Paulo. I think it'll be a great 45 minutes where some of our potential learners have questions around the program, around the MSc, and I think it'll be an interesting interaction. So first of all, thanks a lot for your time again. And just to introduce myself first, my name is Falgun Kompali, and I'm one of the co-founders of upGrad. And most of you must have met me before, either in one of the sessions, in base camps, and somewhere else. But introducing Professor Paulo. Professor Paulo is a head of department of the Applied Mathematics department at Liverpool John Moores University. And his research focuses in advanced data analysis for decision support, in particular with applications to personalized medicine, public health, sports analytics, and digital marketing. Recently, when I was there in 2017, he was also appointed the head of the Engineering and Technology Research Institute, with the oversight of research strategy across the Faculty of Engineering and Technology, and as a project director for the LCR Activate, which is a £5 million funded project to accelerate the development of SMEs in the Liverpool City region. So once again, thanks a lot, Professor Paulo, and it's a privilege to have you here for the session.
My pleasure. I'm glad to be part of this. Would you like me to say something about the university?
Sure. Yeah, I think that'll be great.
Okay. Well, so welcome everyone. I'm going to say a little bit about the Liverpool John Moores University, which is partnering with upGrad on this very exciting new venture for us, which is online learning at a large scale. The university goes back to an institute formed in 1823, then became an amalgam of different institutes, a polytechnic, and finally obtained university status in 1992. Which is now 27 years ago, a long way. It's since grown to 25,000 students from 100 countries, 2,500 staff, 250 degree courses, so we're very big. We also have 13 research centers, one of which is in data science, and is joined between the Department of Applied Mathematics and the Astrophysics Research Institute. The Applied Mathematics Department has regularly come in the top 10 to 15 out of 66 mathematics departments in the country, including all the top universities. So we come somewhere near the top and certainly in the top quartile. Our university mission embeds research and scholarship in everything we do. So for us, this link between research and how it fits into teaching and dissertations is very important. We're going to be pulling that up in this particular project. Myself, you've already heard a lot about me. I am a full professor. I am involved in research in machine learning. I've been for 25 years, and in fact published the first book on neural network applications a long time ago, coincidentally in 1992. I'm also the chair and at times co-chair of task forces in the IEEE Computational Intelligence Society, where I lead task forces on medical data analysis for a while, and on explainable machine learning, which is a topical area of research that's just becoming very hot. So we're interested not just using methods, but understanding what those methods are doing in detail. Now about the MSc program. It's a really interesting value proposition for us. We looked at the program between upGrad and IIIT Bangalore. We took a careful look at the PG diploma curriculum, and we found that's very comparable with what we do here on campus. And we agreed to have this top-up program for the MSc with the Liverpool John Moores University accreditation. And this will essentially produce 70 credits that add to the 110 credits coming from the diploma. The 70 credits on the top-up include two components: a small component of structured learning, which is 10 credits, which is absolutely essential, is structured learning on research methodologies, and a 60 credit component, which is much bigger, of independent learning, which is a dissertation project. And that's really where you're going to get a lot of the benefit for yourself and quite likely for your employer as well, and certainly for your future career. But it's important to emphasize that it's very difficult to do the research project without a proper understanding of the research methodologies that underpin that. So that's really important. Now, the structure of the research methodology course is that we look at what is research, and knowing that many people who've been engaged in taught programs have much experience of the research process. Then we look at how to design and structure a research proposal, because the assessment on research methods will be a research proposal, a detailed research proposal. We'll talk about literature review, because the MSc is all about operating at the state of the art. And to do that, you need to be able to access all of the relevant literature and critically appraise it. And then we'll follow on to research planning, data management, report writing, presentation skills, which is part of the assessment, and scientific ethics. It's an area that I'll be talking about. We'll talk about the principles, the ethical principles, but more importantly, why ethical principles are important to ensure that your research has validity. It cannot be challenged. And what are the implications for people researching data science? And there are significant implications. You may find that particularly interesting. The day-to-day interaction with students on this program will take place with a dedicated postdoctoral fellow who will be resident here at Liverpool John Moores University. So we have everything in place, from lectures through to learner support. And of course, I mustn't forget to mention the online learning platform from upGrad, which is really one of the main reasons why we decided to partner with upGrad. It's an absolutely state-of-the-art platform, and we can see that it ensures a really interactive and immersive online learning experience. So it's an exciting partnership. Very glad to partner with upGrad, and looking forward to working with working professionals in India.
Great. Thanks a lot, Professor Paulo. One of the things that I wanted to ask you was, what about this partnership excites you? The partnership with upGrad and IIIT Bangalore and bringing this thing to India. Is there anything specific that you personally are very excited about? Personally, I'm excited about a couple of different things. First of all, I know that in India you have a lot of strength in the use of mathematics at international level, which means that we have people who will be able to understand in depth the methods that are being used. And you also have an awful lot of strength in computer programming. And that combination means that you got very capable people, particularly if they're already working as professionals. So working with capable people is always exciting. Secondly, India is an economy that's very much growing, and it's also a very large scale economy, and that will provide opportunities for really exciting projects. Projects that might even be on the disruptive interface of the future economy worldwide. So that's also extremely exciting. And that's the fact that we are reaching so many people is bound to create useful opportunities both ways. Absolutely, absolutely. And I think one of the questions that students sent in earlier was, what kind of career opportunities would people with data science and machine learning skills have in the industry, be it in India or be it globally? So they were interested to know what kind of career opportunities would people with these kinds of skill sets have. And one of the specific, and there are a lot of questions around this, but I'll club them all into one, is that people are think that, okay, I come from a banking background, or I come from a retail background, or I come from a medical background. So is data analytics relevant to me? Or for that matter, I come with 3 years of experience, or 5 years of experience, or 12 years of experience. Is data analytics relevant to me? And what kind of career opportunities do I have when I get to a certain stage or come from a certain sector? So any light you would like to throw on that? Yeah, it's a very good question. Data is becoming the common factor for almost everything, and also in industry, and also in government, in fact. So we essentially come into the 4th industrial revolution, which is around the use of data and the use of networking. We'll be focusing on this program on the use of data. But every company employs someone who's analyzing data, and every business model depends on best use of data in order to gain an edge, a competitive edge over their competitors.
In fact, the use of data now has become the engine of the economy. It's become as important, it's really as fuel, as steam, petrol, oil has been in the last century and the century before that. So what makes data even more interesting is because that it's so flexible. There's technically, the only limit in the use of data is our imagination. And if you look at companies that have grown hugely successfully over the last few years, they are the companies that have asked questions nobody else asked, and then had the technical ability to make that come to fruition. So being able to ask smart questions is really at the essence of the digital revolution. And data science is the tool that enables people to take those smart questions and turn them into commercial products. So everywhere from hospitals and health services through to banking, through to small enterprises, through to digital marketing, the common factor is not just the analysis of data, but more importantly, getting value out of data. And to do that, you need to understand your business, but you also need to understand how to access and manipulate data in a robust way, which is where the academic bit comes in. Because one of the things we also learned is that if you don't know quite what you're doing when accessing, managing, and processing data, you may think you got predictive models, but they might not be very accurate.
Yeah, no, that's very interesting. And the other stat I give to most people who ask me this question is that even if you look at the PG program that we have at IIIT Bangalore, the demographic that we get is widely dispersed. And that kind of gives you a sense that people are finding applications and value in learning data science and machine learning across the spectrum. So roughly 33% of our learners are 0 to 5 years. Then there's another 33%, which is 5 to 10 years. And there are 33% people who are 10 plus years experience. So you can see that it's almost evenly split in terms of how people are finding value. And even when we talk about sectors in India, one of the interesting things is that 50% of our learners obviously come from the IT industry, because it's huge in India in terms of how many working professionals are working there and how relevant these programs in data science and machine learning are. But the interesting thing is that the other 50% are split very well across sectors. There are a lot of people from banking, from retail, from telecom, healthcare, marketing, even manufacturing for that matter. There are so many people who work in manufacturing and especially in oil exploration who do this program and are successfully able to apply it in their jobs or even change careers. So it's very interesting how widespread the applications of data are, be it in terms of your years of experience or in terms of the sectors you come from.
Absolutely. I mean, you just touched there on the area of manufacturing. I think that's where a lot of the opportunities are, because manufacturing has traditionally been very machine-based. But the scheduling of manufacturing process is absolutely critical to the efficiency of the factory or production line. And one of the key aspects of that is maintenance. So predictive maintenance, and being able to identify when pieces of equipment require some form of taking offline and being fixed, but to be able to know that in advance, to be able to detect problems when they are early, as soon as they arise and before they become very damaging and expensive, and being able to plan that process so you can integrate the maintenance into the normal production cycle. I mean, these are things that require good use of data. They are non-trivial problems, and they're problems that now be analyzed. And I think that's one of the opportunities that's going to be one of the most profitable in the near future.
Yeah. And now that we have discussed that, look, the applications of data are varied and you can always find value in that. One of the other questions that some of the learners asked us is, how does this MSc program prepare them to successfully take on these opportunities in terms of what the curriculum is, how it is being taught, and what kind of mindset and framework are we putting in place so that students who go through this program will successfully take on these opportunities?
Right. I think the thing to bear in mind there is, first, that the topper program sits on top of the postgraduate diploma, and the postgraduate diploma already gives you the key tools to be able to program at scale, to be able to analyze data in terms of theoretical methods, and also some background into particular areas that are related to your capstone projects. Now, those are the fundamental tools. Now, the thing that now bridges those tools and exploiting opportunities is the definition of a research project that enables you to explore those tools in practice in a real environment. And therefore, the choice of research project is very important. People come on this program should think about their potential in prospective career development and use this project to be the proof of concept that they can bring to an employer about how they can use data to add value to that employer, or they can use it as a proof of concept to start a new company. So it's important that when deciding on the research project, you're not looking back at the methods and how to apply the methods in terms of examples of any sort, but rather looking forward into how you want to take your dissertation and use it to further your career, and then link that with the methods that you've been learning.
Makes sense. Just one question out of curiosity I had. This is my question and not any student's question, because you mentioned that you had written probably the first book on neural networks back in 1992.
On applications of neural networks.
Applications of neural networks. How have you seen this evolve over the last 20 years? I think
applications of networks. You mean?
Or a subject like machine learning, a slightly broader one. Because right now there are a lot of people talking about it, there's a lot of activity, but I'm sure it has been going on, the research, for a long time. So how have you, in your experience, seen this evolve over the last 2 decades? And what do you think is different now, and why is there so much noise about it now, specifically in terms of the kind of attractiveness that companies are looking at it with?
In fact, while you're there, I might be able to even show you. Yeah. This is it. This is the book. Okay. What's interesting about machine learning and neural networks is that the research right up to 1985 was very little research. You could count the papers in the area of neural networks and what we now call machine learning on the fingers of 2 hands each year. Very, very few papers. Then in 1985, a paper was published by Jeffrey Hinton, McClellan, and somebody else whose name escapes me, I think Williams. And that paper was explaining what's now called a neural network looks like in terms of multilayer perception, and explaining that has potentially universal approximation capabilities. That paper was published in Nature. I was working in industry at the time, and I just fell in love with that paper. I just thought, this is what I want to do. So after that, I looked to go back to university and start that research. But that paper actually ignited the field. So in 1986, there was some small neural network conference. In 1987, they're huge. In 1988, 89, there were hundreds and hundreds of people, and everybody was using neural networks. But actually, most of these applications were really, really poorly designed. And even many of the theoretical papers are very poor. That led into an interface between neural networks as a field and statistics, because people realized that neural networks as a predictive model were actually a field of statistics, multivariate statistics. They were nonlinear multivariate statistics, and they couldn't really make neural networks robust unless they understood statistics. And that's how also I was driven to come back into a university from what I was in, which was an engineering department, into what this is, which is a mathematics and statistics department, right? But my background is mathematical physics, so I could switch between the two very easily. So since then, and in the last 20 years, I would say there is a huge number of research publications, a significant proportion of which are very little value. There are many examples of research publications where if you try to replicate the results, they won't work. And that's usually because there are problems with the model, there are problems with the data, there are artifacts, and it's very easy with these very powerful methods to get very good predictions by exploiting failings in the data. Okay, exploiting shortcuts that you don't realize, but put the answer in when you somehow through some shortcut. As a result of that, I think we're now at the threshold of a new revolution, which is about explainable machine learning. Because when you start interpreting neural networks and you're able to make the link between which aspect of the data is being used by the model to make a prediction, you suddenly realize that it's not enough to have good predictions. You need to have good predictions for the right reasons. And with observational data, usually that means more than one iteration. Previously, people said, here's data, get a model, good prediction. Now they say, right, do that. Then you'll find that there are problems with the data. fix the data, do it again, and keep fixing the data until your predictions are robust. That the second and third iteration, those further iterations haven't happened before, except in very few cases, and they are going to become routine. And I think that is what's going to make neural networks really useful. And that's beginning to happen just now. Explainable machine learning has just become a hot topic over the last 5 years or so.
Very interesting.
Now, how much of that we're going to do in this program, I'm not sure. I think we will probably try and do that as much as we can, because if you want, the USP of my research group is explainable machine learning. And I think we will be encouraging everyone who uses these methods to interpret what they do in a way that's not done in lots of other universities.
Got it. Great. The next question, Professor, was around the curriculum and the course structure, which you touched upon. So I'll just briefly explain it again to our learners. So the initial PG program that is designed, so taking a step back, a typical master's program is about 180 credits, right? So in the PG program that you do in the first 11 months or 12 months accounts for about 110 of those 180 credits. And beyond that, as Professor mentioned earlier, there's a 70 credit top up, which is 10 credits of research methodologies module and a 60 credits master's dissertation project. So all of this together is a total 18 months MSc, which adds up to 180 credits. Professor earlier talked already about the research methodologies module, what we're going to cover there and why those aspects are very important. And Professor also talked about the dissertation project in terms of those projects. Some projects are going to come from Liverpool, John Moores University. upGrad is working on creating some projects with the industry in India. You can bring some projects from your workplace, and they have to obviously qualify as complicated and relevant enough for a master's project. But that flexibility is there, and you will be working end to end, and you'll be doing some independent research work for 6 months or 5 months on the dissertation project to complete the entire master's. But briefly, also talking about what happens in the 11 months before that, you will see that in the case of data science, we start with a preparatory program where we give you access to things like how do you do data analysis in Excel, teach you Python, visualization using Tableau to make sure that your base is set in terms of using all these programming languages. And then we also cover statistics and exploratory data analytics, which includes EDA, hypothesis testing, inferential statistics, data visualization. And you will be going through various case studies across this to make sure that you apply all of these learnings. Then in data science, we have machine learning 1 and advanced machine learning, where we talk about concepts starting from linear and logistic regression to support vector machines to supervised and unsupervised learning. And obviously in the advanced machine learning part, we talk about various models like advanced regression, boosting, tree models, time series, neural networks, the professor just talked about, and how do you do model selection with practical considerations in place. Then we talk about big data and SQL, and then you do an elective either in deep learning or neural networks. There is natural language processing, and then there is a domain elective in either healthcare, e-commerce, or BFSI that you guys have to pick up. So as you can see, the first 11, 12 months is going to be fairly rock solid as well in terms of making sure that Professor mentioned this earlier, that the base for you is set up in terms of understanding all the theoretical concepts and also applying them to case studies. So if you look at either the data science program or the machine learning program, we have 400 hours plus of content. There will be more than 7 to 8 case studies and projects that you will be applying those learnings on. You will have various coding assessments, tools, softwares, and live sessions. And I think that will set up the base for you to successfully then move towards the next 70 credit phase, where then you will start to understand how to do research and how to set up a project proposal, etc., which is the research methodologies module. And then finally use all of this to successfully execute on an independent research project, which is going to be very interesting. And you can pick up projects either from the ones that we have in place or something from work, so that you solve that end to end using all the knowledge that you've gained. So I think the way it has been designed to make sure that it's extremely seamless and you have a complete understanding of the subject area, both from an academic rigor point of view and also from an industry relevance point of view, so that when you get to the job, you can hit the ground running. So that's broadly on the curriculum and the course structure. The next question, Professor, I think your point of view will be very helpful here is a lot of students, now they're applying for masters, but would want to have the option or are interested in going ahead and doing a PhD. So how does having a master's help people for their PhD applications?
Absolutely. The definition of a master's is that it operates at the state of the art. In other words, a master student should be aware of the academic literature and should be applying the very best methods to their project, the very best existing methodologies that we pick up from the literature. In a PhD, you're trying to develop the state of the art, to come up with new methods that nobody has done before, and they are potentially publishable. And normally that's a requirement for the PhD. So understanding the state of the art is clearly a requirement if you're going to try and push beyond the state of the art. So the MSc is an essential criterion for the foundation, laying the foundation for a PhD. But there's also another aspect. And that aspect is that because a PhD is about discovering new knowledge, it's at once exciting and terrifying, because it's exciting because it's looking into areas nobody else has looked at. And it's terrifying because what if you don't find something that you can solve, something that works? And the only way to try and manage that tension is to do some form of proof of concept. And the master's is the best way to take a little bit of a risk, to do something, to explore an area, to find out what are the strengths and weaknesses of that area, what is really easy and what is really difficult about an area of research. And by the end of your master's, you should have a very clear idea of where the PhD directions are that are feasible. So for people who may be interested in pursuing research, the master's is the first step to defining the PhD. You can almost treat it like the first year of a PhD. And it in fact includes a literature review, it includes access to data, it includes preliminary applications on data, it includes defining research hypotheses and testing them in a proof of concept way. Those are the steps that are involved in the first year of a PhD.
Yeah, perfect. Makes sense. The other question, Professor, and I've answered this question a lot of times, I don't think there are any strict definitions. But somebody wants to understand what is the difference between a machine learning engineer and a data scientist role, if there's any defined difference in that sense.
Yeah. The main difference, in my personal point of view, because as you point out, there are personal views on this, but for me, the main difference is that a machine learning engineer is someone who knows how to access machine learning methods in software and apply those to data, in the sense of the computational task of taking a data set and running a program, which is a machine learning algorithm on them, and obtaining the results. A data science person is a person who takes more of a big picture view of things. And is the person who decides when the data are ready to be processed, does some preliminary processing on the data, then decides whether statistical methods or machine learning methods are important and which ones are the most relevant, and then interprets the results.
Professor, yeah, so I just, my laptop was on the verge of shutting down, so I had to go and get my charger.
Okay, so anyway, so the answer I gave was that essentially the data science person should be a more rounded and strategic person than the machine learning engineer.
Yeah, yeah.
They need to understand the data, and they need to understand whether the results make sense.
Yep, makes sense. And one of the other questions that we frequently get is that can anybody with a non-computer science or non-mathematics background become a data scientist?
Yeah, very good question. And the answer is absolutely. Of course, you need to be able to understand mathematics, and you need to have the ability to learn to program. And those are things which seem to come naturally for a lot of people in India, given that you have so many people who are good at both of these things. So prior knowledge is not essential, but the ability to learn and the ability to code and to learn how to code, if you don't already code, they are essential. Provided you have those abilities, then there's nothing in this program that you can't learn.
Yeah, yeah. And the other question was, how is the online degree different from the offline degree, and is this relevant for a PhD? So I think Professor has answered that question earlier. And there's no difference between the online and the on-campus degree. They're the exact same certifications. Because I think, as Professor mentioned earlier, the team at LJMU took a very close look at the curriculum that we have already in place for the PG program. And then the top of that has been added, and the entire flow is very similar to what happens on campus. So the certification will be exactly the same. And as Professor mentioned earlier, the MS degree or the MSc degree is going to be crucial and an important step for you if you're interested in pursuing a PhD. The next question is, I would like to start a services-based company in machine learning. So would this course help me in any way? And is there any service-based thing that we can do in machine learning was the question. So slightly open-ended question, Professor. Is there anything that, that you have with this?
Well, whenever starting any business, the first thing that you do is to look at who is the competition, okay? Right? And there are quite a few service companies operating in machine learning. Some of them are big players like IBM, others are like SAS and so on. The second thing to consider is that machine learning by itself is not particularly useful. You need to access data, and often the bottleneck is the access to data, right? So most companies will have data in large databases using SQL or something like that. You need to be able to access those data sets, and not everybody knows how to do that. This course teaches you how to do so. There are, in my mind, the opportunities are less so in the provision of machine learning capabilities and more so in the consultancy on how to get value out of the use of machine learning capabilities. In other words, helping people to derive value from the application of machine learning.
Yeah, yeah. The other next question was, please elaborate on the nature of the projects in the program and in the dissertation. So just I'll list down a few projects that we've already got from Professor in Liverpool John Moores University. There are very interesting projects in the areas of investigating dietary patterns, investigating diagnosis of eye diseases using imaging, structural medical images with information geometry. Then if you move outside of health, then there's using social media feeds to place tweets regarding natural disasters on a map. Preventing credit card fraud through pattern recognition, developing a recommendation system for a media giant, then risk modeling for financial activities and investment banking. There are other projects that both LJMU and upGrad are working on, which we can put in place for our learners to get more diverse choice. And the other thing I mentioned earlier was also that learners are free to bring their own projects from work or from anywhere else if there's something interesting that they're working on. And of course, it will have to go through the rigor of being made sure that the project is has the right kind of depth, can be solved in the time period of the particular program. All of those we will make sure of that and then approve of that project. But there are some very interesting projects that have been put together so that students can get the choice to pick depending on their research interests. The next question was, I'm currently I'm going to complete my PG diploma, and is there any specific time to upgrade to masters, or can I take a break and then join the masters? Yes, I mean, then you need not do it immediately. You can always decide to do it 3 months, 6 months, 2 years down the line. So I don't think that should be a problem. But one of the things that I do observe is that once you take a break, right, it becomes very hard for people to come back because people fall into the routine. Given that you must have completed the 12-month program and you already have the routine of dedicating 12 hours and the discipline of dedicating 12 hours a week, it might be just easiest to continue it in one stretch. But if there are reasons like you're traveling, there's something personal, you can always come back and do it later. So that should not be a problem. The next question, Professor, maybe you would like to give your view on this is, since it's an online platform, how will this exposure help me get a new job in this domain? Or how will it make sure that I have enough rigor in this particular subject? My current domain is EMC storage and networking infrastructure. So I think the question is more around, given that this is an online platform, will this exposure help me with the industry and careers in general?
Okay, the online platform shouldn't have any negative effect, because there will be interactions with the postdoc, and there will be the ability through the postdoc to ask questions that may require faculty support. But I think the most important point of the answer is that the online mode of study enables students to work on their projects that are relevant to their companies, and also to have flexible timescales so that they can integrate their research into the workplace. And that produces enormous benefits that you cannot often do on campus. So I think the online is very much more of an opportunity than anything else, because it provides the vehicle, probably the only practical vehicle, to be able to link your academic work with your relevant career path.
Yeah, yeah. The other question was on the career support. I'll try and answer this question. Where during the course, right, the entire 18-month course, there will be career support services that we provide as part of the program. So what we do is, obviously the academic part itself is very important, right? All the skills that you pick up, the languages, the fundamentals of data science, algorithms, etc. All of them are all the technologies. It's going to play a big part in your understanding there. So the way the course is designed and the rigor with which it is designed should give you a strong hold on the academic concepts. And that's one part of it, what the employer is looking for. The second part is obviously the softer aspects, where we see that people get great grades in the program, but then go and mess up the interview because they're not able to answer simple questions like tell me about yourself or explain a project well, because they're not good with the softer aspects. So that's where there's a lot of career content that we have created and it's integrated as part of the program, where you will, starting from basic stuff like how do you make a CV, right? And how do you talk about a certain project that you worked on, or how do you prepare for an interview, or have a more holistic sense about what's happening in the industry as just compared to what you've done in the course. So I think all of those polishing of softer aspects is done as part of the program to make sure that apart from the academic part itself, the non-academic softer elements are also taken care of. And then finally, of course, the last part of it is that bridging our students and the employers, where we work with a lot of companies. As you might have seen, we have corporate partners like Uber, Gramina, Genpact, Cognizant, Fractal, where all of them provide inputs for the program, starting from case studies to subject matter experts. And one of the fundamental reasons why we do this program is because all of our corporate partners are always saying that we need more data science and machine learning talent. So what we do is that we go back to them and say that, look, now we've developed the curriculum with you. You were part of delivering this whole experience. Now there are X number of students who have passed out and have done that very successfully. So now why don't you look at absorbing them into your own companies? So that's where we make that final mile introduction as well. And hopefully with the academic rigor that you've gone through and the polishing on the softer aspects, it should really increase your odds in terms of converting those opportunities and moving into these new roles. One of the other interesting things that we observe is that a lot of people also change their role, but not necessarily the organization. So say, for example, some of these massive IT companies that we have like Infosys, Wipro, TCS, have increased focus and are building very large teams around digital and data. And they are recruiting for those roles within these companies, and they're recruiting from outside, but they're also moving people from other departments internally. So we see a lot of people in the program who move from, say, a certain team in TCS to the analytics team, or from a certain team in Infosys to the analytics or machine learning team. So those internal transitions are also very promising because you're getting to do much more exciting work and also build a much more sustainable and fast-growing career in the long run. So those are the kinds of career support that we offer as part of the program. The next question is, Professor, for you. Professor has pointed out a very critical point on access of data. For the projects in this program, where do we get the data?
Very good question. This is where some of the projects that are being identified already by the team will provide some data. But for most of the projects that are sourced by the individual student, the student will have to provide the data. Okay. Now there are two sources of data that can be used. One is public domain data, and there are a range of public domain sources of data. There are various repositories and etc. that can be used. And there are proprietary data sources which may be related to your job. And that using that kind of data is absolutely fine, provided that you have signed non-disclosure agreements, provided that there are non-disclosure agreements signed with the program. And that will need to be discussed, and that will need to be arranged.
Yep.
So we've been flexible as to what data are used. We have students working in other programs here using data from companies, sometimes operating within the company, but we do sign non-disclosure agreements.
Yeah, good. The next question is around, is this degree valid globally from a job perspective? How will the companies perceive it? So just to answer that question, a UK master's is obviously accepted in the UK, but it's accepted in the US, Australia, and other countries. When it comes to India specifically, from an employer standpoint, all employers recognize the value of a master's. and it is treated with a certain amount of seriousness and rigor. When it comes to the Indian university system, unfortunately, the Indian university system is not mandated to recognize the UK masters. And if you've seen articles in the press, you will see that there's a lot of lobbying going on to make sure that the Indian government accepts UK degrees, but it's going on for a while, so we never really know when that's going to happen. But that should still not impact you significantly if you're looking at it from an employer standpoint, because I think they still get the value of a master's, be it from a UK or US or Australian university. Specifically for people who have asked questions around PhD applications in India, and given that this master's might not be accepted, what is the status there? Professor talked about this earlier, but there are two kinds of PhDs, one which requires you to have a master's and one which does not require you to have a master's. The one where you do not require to have a master's, then it'll add to the profile that you have, it'll add to your chances of success and maybe reducing your tenure, so that's fine. Where master's is required, some university, so the government does not mandate these universities to accept UK masters as a master's, but it is on the discretion of the university to decide whether or not they want to do it. So there is a certain risk, to be very honest, that some universities might not. But most good universities, including IIIT Bangalore, have said that, for example, if you apply for a PhD in IIIT Bangalore, their minimum requirement is that you have a master's. And given they're part of delivering this, they would accept this program as a master's and let you apply for the PhD. So that's on the global acceptance of the program and specifically a UK master's. I'm just checking if there are any final questions. The next question is, placement assistance will be provided after the completion of the PG program or after the 18-month program. So what we typically do is that 6 to 7 months into the PG program, when we feel like you've covered enough academic concepts, which is after advanced machine learning that I mentioned earlier, is when we start preparing you for career opportunities. So it's actually much more into the 11. We don't even wait for the 11-month program to end, but we wait for the 6-7 months to end to make sure that you've covered enough of the academic concept, and then we start exploring new opportunities. I think pretty much that's it. The final question was on timelines and process. So I don't want to go into too much depth around that, but the cohort launches on April 1st, and the admissions for this are currently under process. So if you have any questions around that, please do visit our website and you can leave your information there, and one of our senior counselors will get in touch with you to explain the whole process and how to take it forward. But I do recommend you to do it at the earliest, because it's the first cohort. One of the discussions that we had with the LJMU faculty was also that we want to keep it slightly tighter and smaller, because there's a lot of load that is involved in terms of dissertation projects, evaluation of that. So we will be closing that soon. So if you're interested, you should do it at the earliest, because we'll be closing the batch soon with a limited set of people, and the batch starts on April 1st. So pretty much that's it. No, sorry, we just got one more question. Are we going to get exposure to real-time projects in terms of using data from real-time projects? If yes, how many different projects would we be exposed to?
Not really. I think the exposure to real-time projects would possibly be part of the diploma work, because in the top-up, we focus on research methodology training and then the dissertation. So it's the end part of the MSc, rather than the most of the technical educational part that's already done in the diploma. So that's where there might be opportunities.
Yeah, fair enough. And Professor is right. Even during the diploma program, we have 1 or 2 optional projects that you can pick up, which can be real time. But otherwise, most of them are data sets that are available that you need to work on to solve for a specific problem. So with that, Professor, thanks a lot for your time once again. I think this was a really interesting session. People got to hear your perspective on the university, the course that we're launching, and why we're all really excited to partner and launch this program in India.
Very welcome. Cheers.
Thanks a lot, Professor, once again. We at upGrad are also extremely excited to partner with Liverpool John Moores University and bring this amazing value proposition to Indian learners, where, as you mentioned, I think there are enough people with the engineering and mathematics background already in India doing relevant coding work in the IT space. And this could be a great opportunity. India, in a certain sense, is considered like the IT hub of the world. And I think this is a great opportunity for also India to like upscale and become the analytics or the machine learning hub of the world. And we're very excited to bring that kind of opportunity to the Indian working professionals and learners.
Absolutely, and we're very excited about linking with that opportunity, which we feel is very real.
Perfect, Professor. Thanks a lot for your time, and thanks a lot everybody for joining in today. Hope this was interesting for you and you got something to take away. And look forward to seeing you also. Thank you, Professor. Good day.
Good day.